Hi children, welcome to the online session. Today we will be beginning with the MCQs on inverse trigonometric functions. But let me just relate to you, there are some important points we need to discuss out, we need to explain to you all so that you all get the knack of the MCQs in the right way, in the right spirit, and you are ready to score full marks in all the MCQs based on inverse trigonometric functions. There are certain basic things which I want you to know, so that I will be explaining to you right now, 25 to 30 minute session. After that we can process the MCQs with whatever knowledge we had studied. I think definitely it will add up to your ease of doing and solving the questions on inverse trigonometric functions. So let us begin with this particular part. So the first thing what I want to share with you is about trigonometric function. As we are dealing with inverse trigonometric functions, pay attention, right? So inverse trigonometric functions, inverse trigonometric functions. Now children, very important thing is you must have studied in function when an inverse of a function exists. There are two options. When an inverse of a function exists, when basically the function is 1-1 function and the function is onto function. That means in this case, if the function is bijective, then I can say then inverse of a function exist. I think I am very clear about it. Now let me just talk about only the trigonometric function. I want to talk about only the trigonometric functions. Take a small graph so that we understand it here. So pay attention now. Suppose I am talking about a function, say y is equal to sine x. Now listen very carefully. Very important thing which I am going to share on this. So let us pay attention now. Now you know that for a function y is equal to sine x or a function fx, that is a trigonometric function, it is defined from a real number to a real number, right? So you all know that all real numbers will be the domain and this is the range of a trigonometric function. Definitely it is called function. The reason is I will just explain you with the help of a graph. Now if you see this carefully, a little bit differently, so that you come to know exactly what I am sharing with you. Okay, this is the x axis and this is the y axis, everybody knows that, right? This is 1, this is minus 1, this is plus 1 and this is minus 1. So this is 0, this is, we can draw the sine graph like this and so on. Similarly, it moves in this direction and so on. Now this is nothing but sine graph. Now I am just tentative, I am tearing up, this is 1, this is minus 1. So here it is pi by 2, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi and so on. Similarly on the left hand side you have 0 here, this I can take as minus pi by 2 and this is minus pi and so on. Now first thing I want to share, I am talking about, I am explaining this part, I want everyone to pay attention. Something very important is coming up on the screen. Now when I talk about trigonometric functions, so if I see the definition of trigonometric functions, can you say this particular function is 1-1 function? Let me see whether it is 1-1 function. Let us see this part. Now if you say, look at this, sine 0 is 0, sine of 180 is 0. Similarly, sine of 360 is also 0. What I mean from here, sine of 0 is 0, sine of 180 is 0, sine of 360 is 0. That means if I just want to show it here, so it is 0 degree, 180 degree, 360 degree. So if you see this, this is nothing but many one functions. Sine 0 on the y axis it is 0, sine 180 on the y axis it is 0, sine 360 the y value will be 0. So what I am trying to tell you is that when I talk about a trigonometric function, definitely in this case what I am trying to tell you is that it is nothing but many one function. Agree? So you must say, then if the trigonometric function is many one, I repeat my word, if the trigonometric function is many one, I mean to say, then how can inverse of a trigonometric function exist? Because for a function to inverse a function to exist, it should be 1 1 on 2, but in this case if you see across of all the real number line, from real number to real number, real number to real number, I say that this function is many one, this trigonometric function is many one, hence inverse does not exist. Now the question arises, what I do next, right? I want to study the inverse trigonometric functions. So what I will do is, instead of restricting, or sorry, instead of going from a real number to real number, that is studying real number to real number, this graph, I will limit this part from say pi by 2 to minus pi by 2. It's a convention, okay. So let us see this open. If you see, sine 0 is 0, right? Sine 90 is minus 1, sine of minus 90 is minus 1, sine of 90 is 1. So every part, if you see this value, sine of x, every x value will give me different value on the y axis. You can try it out. See, if this is my x value, this is my y value. If this is my x value, this is my y value. If this is my x value, the corresponding point on the curve is nothing but different y value. So for every x there is a different y, for every x there is a different y. So what I can say in this case, that it is one to one function. So I don't want to just go with this part right now, because this portion I can just remove that out quickly so that it becomes easier for me. I am talking about this line, right? This is the y axis here, okay. Now what I am trying to tell you here is that if I, instead of studying across the real number, if I limit from minus pi by 2 to minus pi by 2 to pi by 2, that is, if the domain, if I limit from minus pi by 2 to pi by 2, what is the range here? It touches minus 1, it goes up and touches plus 1 to, here it is minus 1. So the range is plus 1 to minus 1 to plus 1, or you can do plus 1 to minus 1, whatever it is. So what I am trying to tell you, if I limit this graph, so what happens now quickly, if you see this particular point, right, from here to here, that is, look at this, if this portion I consider from minus pi by 2 to pi by 2, or you can consider pi by 2 to 3 pi by 2, from here also here, you can consider from here to here also, right? But universally what we do is, we always consider from minus pi by 2 to pi by 2, because the acceptable thing in across, practice also across from minus pi by 2 to pi by 2, it becomes 1 1 function. And definitely for every value from between minus 1 to 1, it becomes onto also. It becomes onto also. Anyway, right now what is the message here is that instead of across the real numbers I define the function, trigonometric function, if I define the function for the domain minus pi by 2 to pi by 2, it is not only 1 1 but also onto. That means the domain is minus pi by 2 to pi by 2, and here it is plus 1 to minus 1. Then I say the function is 1 1 onto. Therefore, under this condition, not this condition, under this condition I can say inverse exists. Inverse exists. Okay, so we are studying from minus pi. I'm talking about this trigonometric function, that is y is equal to sine x. Keep that in mind. Now guys, what is important now, pay attention now. So y is equal to sine x, hold on. For this trigonometric function, you can say if this is y is equal to sine x, for this the domain starts from minus pi by 2 to pi by 2, and this ends up to minus 1 to plus 1. I mean to say domain and range of the function. Before we proceed, I want to share with you something important. This values from minus pi by 2 to pi by 2 for this sine trigonometric function, this value is called as principal value. What is called as principal value? So from minus pi by 2 to pi by 2, where the function is defined and inverse exists, this boundary, this value, that is from minus pi by 2 to pi by 2, this is called the principal value of this trigonometric function. Great. So now what happens with inverse? I said that this is 1 1 as well as onto. So as it is 1 1 onto, the inverse exists. I can inverse, everybody knows if a is a number, the inverse is 1 upon a. You can also say a raised to minus 1. So what happens here? So I can denote as y is equal to sine inverse x. I want to write this out properly there, hold on. So y is equal to sine inverse x. Y is equal to sine inverse x. So I believe this is an inverse trigonometric function. For this domain and range, the inverse of this trigonometric function exists. It is denoted by sine inverse x. Now inverse means what? A 1 upon a. So basically in inverse what happens is, children, the domain becomes range and range becomes domain. So x axis becomes the y axis and y axis becomes the x axis. So what does that mean? So basically the swiping will happen here. Now listen very carefully, there is swiping will happen. So that's the reason the domain in this will be plus 1 and this will be the range, that is minus pi by 2 to pi by 2. Very important point. And this range, what it is called, basically I told you, it is nothing but principal value. What is this called? Principal value of this trigonometric function. I mean, with this inverse trigonometric function, this becomes the principal value. So this is what is important. So if I just take the next part, you will understand. First thing what you got from here is that for any trigonometric function, inverse always exists within a restricted domain, and definitely range is plus 1 to minus 1. Plus 1 to minus 1. So we limit it and we study only in this portion. Similarly now, what is inverse? As if when I restrict it from minus pi by 2 to pi by 2, this trigonometric function gets converted to 1 1 onto function. That means it is bijective. So inverse exists. Now actually what behavior happens in inverse? The x becomes the y axis and the y becomes the x axis. So I mean to say, if you want to specifically work out, so this will be nothing but pi by 2 and this will become minus pi by 2. This will become plus 1 and this will become minus 1. Okay, so this will be, somewhat, I think you have to work out like this. Now see, this will become like this. The graph, this was the horizontal way, this becomes vertical way. So right now I am not worried about this portion, this part. What I am interested in telling you is how the graph appears to be for inverse. Anyway, we are not studying about the graph part in detail here. What is important is the domain and range, it reverses. This becomes the domain and this becomes the range. But this range is what? This range is nothing but the principal value of this inverse or of this trigonometric function. So you have to keep in mind this portion, very important, that how I converted the trigonometric function into bijective function, and because of bijective the inverse exists, and in inverse what is the behavior happens? The principal value minus pi by 2 to pi by 2, minus 1 to 1, the domain becomes range and range becomes domain. That's the portion of it. Okay. The next part, very important, is we are coming to the main core part of inverse trigonometric function. So first I just explained to you the birth of the inverse trigonometric function. The next thing will be to really study this topic in detail, in depth, that we will just take up right away. So what is that? The next thing which is going to help you terrifically in MCQs. What is this thing? Nothing but the principal value. Okay, so pay attention now. Okay, as I said, this table is very important table, and it is very useful for solving the MCQs on inverse trigonometric function. I don't want to study everything. I am not worried about everything. What I am trying to tell you is, I want you to know, I want you to remember, I want you to understand the principal value. This portion is very important. This portion. So principle of inverse trigonometric function. What is the principal value of inverse trigonometric function? Sin inverse x minus pi by 2 to pi by 2. Cos inverse x 0 to pi. Tan inverse x this. Cot inverse x 0 to pi. Now something very important is coming up here. I want to just summarize this part in front of you, so it becomes very easy for you. So instead of learning it by heart, you should by default know what is the principal value of sin inverse x, what is the principal value of tan inverse x, what is the principle of cosec inverse x, and so on. So what I observe from here, I want you to just make a note of three things. If you see this minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, and minus pi by 2 to pi by 2. Now understand what is happening here. Please pay attention here. This is very important. Now remember, in this case, the principal value, what happens for this trigonometric functions. That means I am summarizing it so that you don't have to learn it, you can just remember it. So I hope the previous part you really understood this portion, that the principal value happens to be from minus pi by 2 to pi by 2 of sine inverse function. Now listen how I tell you. If you see these three ratios, sine inverse x, tan inverse x, and cosec inverse x. If you see this ratios, right, if you see this inverse trigonometric ratios, the principal value, if you see this, okay, I'll just put it like this, sine inverse x, tan inverse x, and cosec inverse x. So sine inverse x, the principal value is nothing but minus pi by 2 to pi by 2. Okay, pay attention, very important. Okay, second case, let us take cosec inverse x. Cosec inverse x is same thing, minus pi by 2 to pi by 2, but there is a hiccup here. What is the hiccup? I will tell you. So cosec inverse x is what? It is reverse of cosec. So suppose if I say cosec inverse x is theta, because any inverse ratio is an angle. Now for just to understand it, how I do it, suppose if I say sine 30 degree is half, sine 30 is half. So sine goes this side, 30 degree is sine inverse half. So sine inverse of some value is an angle. That means an inverse ratio is always an angle, and in this case what is the angle? 30 degree. So similarly here, cosec inverse x, I just put an angle because the inverse ratio. So I know x is equal to cosec theta. Now if I say x equals to cosec theta, something touches my mind that it is reverse of sine. So it is nothing but 1 upon sine theta. Now tell me this x, for what value it is defined? Or for what value, they make it simpler to you, for what value of theta it will be not defined? For 0 value it will not be defined, because sine 0 will become 1 upon 0, which becomes undefined. So theta cannot be 0. So in short, for cosec inverse x, this is in theta, right? From here remove 0. So that's why they had said here in cosec it is minus pi by 2 to pi by 2 and y is not equal to 0. I hope you got this point clear. So in this case the principal value is minus pi by 2 to pi by 2 minus 0. So from here to here, from remove this 0. Similarly for tan inverse x. Tan inverse x, I take it like this. So suppose tan inverse x is also an angle. So what will happen now? X will be equals to tan theta. Now if I am going to put like this, minus pi by 2 to pi by 2, you know what is the difference? This is included, this is also included. So if I put tan pi by 2 is what? Infinity, undefined at theta is equal to pi by 2. That means when tan theta is at minus pi by 2 or pi by 2, tan pi by 2 will become infinity, undefined. Therefore, I have to remove this bracket and put a round bracket so that we understand between minus pi by 2 to pi by 2. That's what exactly it is given here. That is between minus, this is not equal, there is no equal sign, right? So between minus pi by 2 to pi by 2. So this is better to remember instead of this. So basically there are three ratios, minus pi by 2 to pi by 2, the principal values I am talking about. Sin inverse x is minus pi by 2 to pi by 2, tan inverse x is open interval minus pi by 2 to pi by 2, cosec is reverse of sine, is the same thing but remove 0. Why? Because at 0 degree this ratio will become undefined from this working. So this working is not required, this is just for your understanding I am sharing with you, the first thing. Okay, I hope you got this message. I don't want to learn. So sine inverse is minus pi by 2 to pi by 2, remember my graph. Then cosec at 0 it is not defined, so minus pi by 2 to pi by 2 minus 0 principal value. Tan open interval, because tan 90 is infinity which is not defined, so minus pi by 2 to pi by 2 in open interval. So that's what I am talking about, a similarity between these three. So just now we had done the trigonometric ratio of sine inverse, tan inverse and principal value of sine inverse, tan inverse and cosec inverse. Now after understanding the principal value of this, the next thing which I want to share with you is the principal value of the other three ratios. Now what is the other three ratios I will write here. So if you see what is left out now, cos inverse x, then what is left out here, cos inverse reverse is sec inverse x and cot inverse x. So the principal value of, now if you look, 0 to pi, so from here it is 0 to pi. Sec inverse x, 0 to pi minus, see what happens, minus pi by 2. Now you might ask me, sir, how I got this? Very simple. See, sec inverse x, I'll just work out here. See, sec inverse x is equal to theta. So x equals to sec theta. Sec theta is 1 upon cos theta. Now if I put cos 90, theta is 90. So cos 90 is what? 0. So 1 upon 0. So it will not be defined for 0. Sec inverse 0 is not defined. That is, theta cannot be 0. So from 90 is 0. So 1 upon 0 is not defined. So therefore from 0 to pi I have to remove this pi by 2. And for cot inverse x, as you did for tan open interval, similarly here also open interval 0 to pi. So basically if you want to look at this particular thing, there are only two things. Pay attention. If this is x axis and y, this is, say this is pi by 2, this is minus pi by 2, right? This pi by 2 minus, this is 0 and this is pi. So if you see this part, minus pi by 2 to pi by 2, it is sine inverse, cosec inverse and tan inverse. And if you want to look at the other side, I mean to say, if you want to look at the other side, 0 to pi, this side 0 to pi, if you see this is nothing but cos inverse, cot inverse and sec inverse. This is just for your understanding. I don't want you to learn that part, but what I am trying to tell you is minus pi by 2 to pi by 2 happens for sine inverse, cosec inverse and tan inverse. And for the other three ratios, cos inverse, sec inverse and cot inverse, the principal values are from 0 to pi. So I hope this part and this portion is very, very clear. Now, besides this knowledge, these are I am talking about principal values. Besides this knowledge, there are some additional pocket formulas also which will help you drastically in understanding what is happening across. Okay, how to approach the sum. So, that part, sin inverse x is equal to x, cos inverse x is equal to x, tan inverse x is equal to x, cot inverse x is equal to x, sec inverse x is equal to x, cosec inverse x is also x. Right? Now, its reverse is also possible, same thing for reverse. What happens for reverse, guys? This is nothing but sin inverse of sin theta is theta. Okay, remember sin theta, this is an angle, sin theta. So, or you can put, if you want, you can put x here, there is no problem at all. So, if you want to put x, put it over here, but remember in this case the x is a value, in this case this x will be an angle. So, that is important, you have to remember that. So, I will just remove that so that it becomes easier for you to know it. So, it is x is equal to x, then cos inverse of cos x is equal to x, and same. I mean to say, you can say, if you want, write it down fully, it is tan x is x, cot inverse of cot x is x, sec inverse of sec x is x, and cosec inverse of cosec x is x. Remember, in this case, this is an angle, sin theta is an angle. So, this is a value. Okay, sin theta. Remember, any inverse ratio is an angle. How I understand this? Just make a note here. Suppose if I say sin theta is half, right? So, what I can say here is nothing but sine of pi by 6. So, what is theta? Theta is nothing but pi by 6. Okay. So, similarly, if I take sin theta is half here, so sine inverse half. So, what I want to say and share with you is, this is the point which I want to share. I got sin theta as half. So, what is theta from here? Theta is sine inverse half. So, whenever inverse ratio comes up, along with me there will be some value. So, whenever inverse is there is a value there. Okay. Now, when I say sin theta, here sin theta inverse of theta, inverse of a value. So, sin theta is half in this case. Are you understanding my point? So, this is what is important for you. When I refer to inverse, it is nothing but a value, and in this case, when I reverse sine, value does not happen, it is of an angle. X is an angle. So, anyway, not much thing to understand it. As you go on in the sums, you will understand whether an angle or a value. As we go on, we will come to know. The next part, very important in this is, I just nobody should miss that part, because that is something very important. What are the two sets you studied? In the first set, sine inverse of x, sine inverse, then tan inverse, and what is the other set? Cosec inverse. It is minus pi by 2 to pi by 2, correct? Now, all this will have the same value of with a minus sign, sine inverse x minus tan inverse x minus cosec inverse x. Right? I hope this is very, very clear. Now, what are the second set we saw? 0 to pi principal value. Well, the second set was cos inverse of minus x is nothing but, hold on, it is pi minus cos inverse x. Keep that in mind. Similarly, sec inverse of minus x is pi minus sec inverse x. Similarly, cot inverse minus x, cot inverse of minus x is pi minus cot inverse x. So, the pattern, understand. So, here the principal values everybody knows, it is minus pi by 2 to pi by 2, it is open the bracket, open interval minus pi by 2 to pi by 2, here it is nothing but pi by minus pi by 2 pi by 2 remove 0. Similarly, here 0 to pi for this, 0 to pi for this, minus pi by 2, and here it is open interval 0 to pi. So, that is nothing but principal value. So, if you understood this much, I believe when we go with the next set of questions, you will understand how really to deal with the sums in a better way. I mean to say specifically MCQ which I am talking about. So, I hope you got this message clear, you got the point clear what I want to explain. Let us focus on pocket small questions so that this concept becomes more clearer to us. So, let us see the next questions. So, I hope you have taken it down. So, this is what is important. As I said, I want to take you back again and again to this chart, because this chart is really going to help you terrifically in working out the principal value for a very important, not only for our MCQs, but also for IIT, JEE, CET, whatever exams, competitive exams. This part of the value is very important. Okay, keep that in mind. Our domain everybody knows, for an inverse function this is the domain, and this range becomes the principal value. Okay, keep that in mind. So, I hope you got this clear. Here it is minus 1 to 1 for sine and cos inverse minus 1 to 1, all real numbers. This is, it's okay, it can be workable, understandable, but here I had explained to you exactly this two portion is not that specific that required, but this part is very important. Let us take some sums from here on, and we will see how really we apply what we studied in this part, introduction topic. Okay, let us see this part quickly. Okay, I hope you got this point clear. So, let us take some examples so that you understand what I am trying to pursue it. Okay, so let us take an examples. So, if I say in this case, just a second children, examples. Let us take one simple examples first. Suppose if I say sine inverse of half, basically how we work it out I will tell you. So, I will put this sine inverse half as theta. Okay. So, sine theta will be equal to half. Keep pay attention now, sine theta is equal to half, and in such a way that sine theta is half. So, sine theta is equal to sine pi by 6. So, theta is nothing but pi by 6. So, the theta, this is my sine inverse half is theta, and what is the theta value I got? Theta value I got pi by 6. So, let us take another example. Suppose if I say tan inverse of 1. So, whose value of tan is 1? Pi by 4. Now, this is something very important I want to share. I write in very exceptional way here, that these angles which we get, these angles should be always principal value. That is, the angles are always principal values. So, if I just twist this up quickly, now if I say sine inverse minus half. Now, sine inverse minus half everybody knows, you can take this as minus sine inverse half, right, minus sine inverse half. So, sine inverse half is just now I wrote it 6, that is nothing but minus pi by 6, right, minus pi by 6. But tell me, what is the principal value of inverse function? Inverse function, the principal value is minus pi by 2 to pi by 2. So, tell me, does this minus pi by 6 lies between minus pi by 2 pi by 2? Yes, it lies. Does pi by 6 lies between minus pi by 2 to pi by 2? Yes, it is true. Then here it is minus pi by 2 to pi by 2 principal value. So, my pi by 4 lies between minus pi by 2. This is also true. Similarly, suppose if I have cos inverse of minus half. So, cos half, everybody knows it is pi by 3. So, immediately you do not say minus pi by 3, this is wrong, because cos inverse of minus pi by 3, cos inverse of minus half is minus pi by 3. You can't do that. Why? Because minus pi by 3 for cos 0 to pi, right? It doesn't lie. This minus pi by 3 doesn't lie in the principal value. So this is the wrong answer. Are you understanding my point? Right? So what I am going to do is, I told you now just before, just working with the formulas, cos inverse of minus x, you can directly write down pi minus cos inverse x, right? So whenever the angle becomes negative, in short, if it doesn't fall in the principal value, get the equator angle by pi minus 2 pi by 3. Now 2 pi by 3, how much it comes to? 120 degree. So 120 definitely lies between 0 to pi. So understand how these angles, this angle is coming in principal value is right, this angle comes in principal value is okay, this angle comes in principal value okay, this angle does not come in principal value, it's not okay, negative angle. Cos inverse of minus, if I take minus cos inverse half, this is minus pi by 3, that's what it came. So minus pi by 3 does not fall in the principal value of cos inverse. So that's the reason you have to keep a note of the principal values of the trigonometric function. And this simplification, the inverse of anything is an angle. This is an angle. Keep that always in mind, and that should be compulsory in the principal value. I hope you got this point clear. Okay, let us see the next set of questions quickly. Okay, now let us see the next part. If you see this, if I say sine of, you can say sine inverse, say sine inverse half. So sine of sine inverse half, this is nothing but half, correct or not? Okay, just a small bit of this thing now. So sine of sine inverse x is nothing but x, everybody knows it. So I'll just do it reverse now. So suppose if I say sine inverse of sine pi by 6, right? Sine inverse of sine pi by 6 is nothing but pi by 6. Now this is completely true. You know why? The angle I told you in the previous case, if you see the previous case, the angle should be compulsory within the range of the principal values, right? So here for sine inverse function, what is the principal value? Everybody knows it is minus pi by 2 to pi by 2. So this is done, right? But suppose if I go with something else, for example, suppose if I say cos inverse of 7 pi by 6. Be careful. So sine inverse of sine, every pi by 6, cos inverse of cos, immediately you will jump the gun, you will say 7 pi by 6. So how many students wrote 7 pi by 6? I think many might write, but this is completely wrong answer. I will tell you why. Because 7 pi by 6, this is a cos inverse ratio, doesn't come in the principal value. The angle has to come in the principal value. If not, if it is not coming, the sum is not wrong. You have to do some adjustment and get the angle between the 0 to pi for the principal value for that particular inverse ratio. So in this case, definitely 7 pi by 6 will not be the output. So I hope you got this point. So what I am going to do? I am going to do some adjustment. What is the adjustment I am going to do? I will just share with you. Pay attention. This is cos inverse cos. I can write this as, this is cos positive, right? Cos, it is positive. So positive is in the first quadrant and the fourth quadrant. So 2 pi minus 5 pi by 6. Just see what is happening now. 6 2s are 12. 12 pi minus 5 pi is 7 pi by 6. Now 5 pi by 6 for the cos inverse ratio, 5 pi by 6 means 6 is 150 degree, correct? So this comes in the principal value. So 5 pi by 6 would be the answer. But the question arises, student would ask me, sir, you directly wrote 7 by 2 pi, how you are going to understand? See, first thing is cos is positive. So it will be first quadrant or the fourth quadrant, right? So what I can do is, I know fourth quadrant is 2 pi, say minus a. I want, what is the value I want? I want 7 pi by 6, correct or not? Because it is the fourth quadrant. So 2 pi minus a, let us find the value of a. So 2 pi minus 7 pi by 6 is equal to a. So if I solve this out, 12 pi minus 7 pi, 5 pi by 6 is a. So this part, that is 2 pi minus 5 pi by 6, I am writing here. So now cos inverse of cos becomes compatible. So what is it? 5 pi by 6, and 5 pi by 6 definitely falls in the principal value 0 to pi because the cos inverse ratio. That means my working is absolutely right. I hope you got this point, children. So, we will see now the MCQs as we go on, because once you understand this basic tenet, many of the MCQs you will be able to do on your own. Okay, but I will share with you how I really think based on this particular thing. Remember, whether we begin or end, this chart is very, very important for us. Principal value for sine inverse, tan inverse and cosec inverse is minus pi by 2 to pi by 2, whereas for cos inverse, cot inverse and sec inverse it is 0 to pi. Keep that always in mind. I hope you got this point, children. So, go through this lecture again and again, understand what I am trying to share with you, okay, and then we will start the MCQs in a very positive note. Children, I believe that most of you must have visited the previous session, that is the foundation of inverse trigonometric function, what is required. I just posted a special video for that. So, after you understood those things, so now we will look and turn our focus towards MCQ, and I believe that most of the questions you will be able to do on your own, but definitely just support for you all. I am doing the first set of MCQs with you all. So, I hope you will enjoy this session. So, children, let us begin with this particular thing. The first question comes up, in fact, which of the principal value branch cosec 4x. Now, remember, I had specifically told you all before also, that this principal value is also called as principal value branch, okay, that is PVB. Keep that PVB. So, keep that in mind. So, anyway, coming to a point, if you, this is cosec inverse, I beg your pardon here. So, do not mess up with this, there is some typing error there, just a second guys, minus 1 cosec inverse x. So, if you remember this cosec inverse x, what is the pattern here? So, what is this thing? Let us see. If you see cosec inverse x, what is the principal value? Cosec inverse x, I told you, look at this, minus pi by 2 to pi by 2 except 0. Okay, keep that in mind. So, here we go guys. So, minus pi by 2. So, cosec inverse x. Now, I want to find the principal value. Now, if you want, let this be theta. Actually, the direct answer there, that is the fourth answer, is the right answer. So, how I get it? I can write x as cosec theta. So, remember, x is equal to 1 upon sine theta, right? Now, remember, I told you the 3 set. If you remember, the 3 set which I shared with you was sine inverse, cos inverse, tan inverse and cosec inverse. Now, all this, if you see, this is minus pi by 2 to pi by 2 except 0, right? If you remember, this, just if you refer the video which I just posted, because sine 0 is there, so theta cannot be equal to 0, because theta becomes 0, 1 upon 0 becomes undefined. So, 0 cannot be the part of the answer. So, this is minus pi by 2 to pi by 2. From here, remove 0. So, that will be the value of the x belongs to. So, I hope you got this point clear. The option is D. So, a simple way of looking at it, simple way of working of it. Okay, I hope you got this point clear. Let us take the next question. Now, the domain of the function. Now, if you look at the carefully there, I just purposely posted this over here. So, the domain of the function. Now, look at this pattern here. The domain of the function, the domain, if you see the domain of cos inverse x, remember, sine inverse or cos inverse is always from minus 1 to plus 1. Keep that in mind. So, this I am talking about domain. I am not talking about the principal value. Okay, I hope you are getting this point. So, the domain is between minus 1 and plus 1. So, if look at the pattern here, cos inverse x The domain is x is greater than equal to minus 1, less than equal to 1. Now you tell me this x is replaced by 2x minus 1. So I can say like this, x is replaced by 2x minus 1 less than equal to 1. Now I will just solve this in a two way, minus 1 less than equal to 2x minus 1, 2x minus 1 less than equal to 1. Now what happens over here guys, minus 1 minus cancel, so 0 less than equal to x ho jayega, or say x is greater than equal to 0. In this case x will be greater than equal to, x will be less than equal to 1, sorry, x is less than equal to 1. So simple way of working, I am talking about the domain. So if I combine this both, x is greater than equal to 0 and less than equal to 1. So can you tell me which is the answer option? So x, the domain means x, so x value has to be this thing. So when I say domain, you have to focus on this because this is cos inverse function. So in general, cos inverse x, domain is this, right? But this x is replaced by 2x minus 1. Just place it over here and solve it. That's the pattern we go with the solution. So this is the solution. So I hope you got this point clear. Let us take the next question, guys. Fourth one. The value. Okay. Now sec inverse 2. What I can do here to just make it simpler. 2 cos inverse 1 by 2. Sec inverse is reverse of cos. 2 cos inverse 1 by 2 plus sine inverse 1 by 2. Now cos inverse half. Remember, any angle value you get, it has to be within the principal values of it. So I told you any angle has to be within the principal values, within the principal value branch. Okay. So cos inverse half. Now whose value of cos is half? So 2 into what happens now? It is nothing but pi by 6, pi by 3, right? Plus sine inverse half, pi by 6. So you have to just calculate this out quickly now. So 2 pi by 3 plus pi by 6. So what is the LCM here? 6 is the LCM, 3 2s are 6, 4 pi plus pi. So answer is 5 pi by 6. So I think 5 pi by 6, the answer is option B. Option B is the answer, right? I hope you got this point clear. So it's simple working, understand the working of it. These are standard values, but ensure that whatever angles you are writing for this, it has to be compulsory within the principal value branch. Keep that in mind. Okay, you already know what is that. Next question. The principal value of cot inverse of minus root 3. Now here I am not going to help you out, or you can try, or I will also try with you all. It's not that I just have to give it to others. Now remember this, I had specifically told you in the beginning when we did, I did the video in the previous presentation that cos inverse of minus x is nothing but pi minus cos inverse x. Similarly, cot inverse of minus x is pi minus cot inverse x. So I had clearly specified this. Now you might say why I am doing this, I will tell you what it is. Cot inverse of minus, this is nothing but cot inverse of minus root 3, right? Now cot inverse of minus, everybody knows it is minus. Cot inverse of minus root 3, I can write this as pi minus cot inverse root 3. Now root 3 value, it is pi minus cot inverse root 3 is nothing but pi by 6, right? So I think cot, whose value of cot is root 3 is pi by 6. So answer is 5 pi by 6. So but before that, cot always comes, the principal value is from between 0 to pi. So 5 pi by 6 means 150, right? 630s are 150. So 150 comes between 0 and pi. That means this option is the right option. So answer is some number, option number A. So I hope you got this point. So any angle you get, it has to be within the principal value. Keep that in mind. So here it's very clearly specified. See, cot, it is cot inverse. So cot inverse is here. What is this? 0 to pi, right? Between, from 0 to pi. I am sorry, from 0 to pi it is. Okay, keep that in mind. Next one. The value of tan inverse root 3 minus sec inverse of minus 2. So first thing is I will just write this point clearly just for information. This is tan inverse root 3, okay, minus sec inverse x is cos inverse minus 1 by 2. Sec inverse x is cos inverse 1 by x. But just now cos inverse of minus x, pi minus cos inverse x, right? Pi minus cos inverse x. So what I am going to do is, I will just keep this as it is, just a minute, minus this cos inverse of minus x, I can say this is pi minus cos inverse x, correct? Now let us see what happens. Tan inverse root 3 is pi by 3, everybody knows that, minus pi, minus of minus become plus, cos inverse half is pi by 3 again. So 2 pi by 3 minus pi, if I find the LCM here, this will be 3 and this will be 2 pi minus 3 pi. What is the answer? Minus pi by 3. But remember, the value of sine inverse of cos 3 pi by 5. Now look at the question there. This is a simple question there, okay, simple matlab is not so simple. It is sine inverse of cos of 3 pi upon 5. Now be clear, okay, 3 pi by 5, definitely this is sine inverse is nothing but minus pi by 2 to pi by 2. Okay, so let us see the next question there. If you see this question here, let me just write it down. This is given sine inverse of, okay, it is cos of 3 pi upon 5. So if you see this, 5 3s are 15, 5 6 are 30, 3 6 are 18, 3 are 9, 10. So 108 degree. But sine inverse, remember the principal value has to be between minus pi by 2 to pi by 2. So you cannot change, you can change this to sine, but before that you have to simplify this and make it come under the principal value. Anyway, what I am going to do is just say sine inverse, can I write like this, cos of 90 plus theta pi by 2 plus cos 90 plus theta. So what I can do here is pi by 2, I want 3 pi, pi by 10. So I think it's workable, right? Pi upon 10 is 18 degree, so definitely below minus pi by 2 this thing. Now cos 90 plus theta, 90 plus theta is second quadrant, so this is nothing but sine inverse of minus sine pi by 10. Am I right? So minus sine theta, so you know this sine inverse of this I can write off sine of minus pi upon 10. Okay, so answer is minus pi by 10. But any angle for a single ratio, inverse ratio, you should always remember it belongs to minus pi by 2 to pi by 2. That means my answer is right. So minus pi by 10 is the right answer. I hope you got this point clear. It's not difficult, you have to just really have patience and work out with it quickly and fast. Okay, next question. Now the principal value of cos inverse half plus 2 sine inverse half plus 4 tan inverse 1 by root. It's a big equation there. I can work out directly there. Simple question it is cos inverse 1 by 2 plus 2 sine inverse 1 by 2 plus 4 tan inverse 1 by root 3. Can you have a check? They are all standard angles. Can you just try it yourself and give it? I give you 30. Cos inverse half. Cos inverse half is, I think, pi by 3. Yes. Plus 2. It will be pi by 6. Then plus 4. It is 1 by root 3 is pi by 6. And see what happens, guys. So 2 1s are, 2 3s are, 2 2s are, 2 3s are. So pi plus 2 pi upon 3. What is the answer? Is it 4 pi upon 3? So principal value of this matches, principal value of this matches, principal value of tan inverse ratio also matches. I think all the principal value gets added and gets the equivalent answer for this. Is it 4 pi by 3 is absolutely right answer. So this is the way you have to deal with the question. Okay, I hope you got this point clear, right? Very special pattern of question, okay, very special pattern. You know why? I will tell you. See this question, this is tan of given, it is half cos inverse root 5 upon 3. Okay, I have no issue at all. So I have to understand how you really go. See, when you can't proceed with the sum, see if it is not like this, then use a right angle triangle. You can get the tan ratio, so tan of tan inverse, your work gets over. But this half is a troublesome thing. These type of sums you can always do best by using substitution technique. So what I am going to do is, I am going to use my little brains which is well trained. So what I will do, I will say let cos inverse root phi upon 3 be theta. So what will happen here? This will be cos theta is equal to root phi upon 3, just for your information. Okay. So what will happen eventually here? Let us see. So this will become tan of half cos inverse x. Now cos inverse x is theta, so this is nothing but theta. I am very glad. Now tan theta by 2 I can write as sin theta by 2 upon cos theta by 2. Now you might understand why I did this. I will share with you 1 minute. Now I am going to take you to some formula there. If you remember, 1 plus cos 2x. What is 1 plus cos 2x? 2 cos square x. 1 minus cos 2x is nothing but 2 sin square x. So based on that pattern only I am going to get it. Now which is equal to, pay attention here. Now I am talking about the denominator. Okay, cos x by 2, see double has become single. See, double has become single. So cos x by 2 will be cos x, right? So this will become what? Square root of 1 plus cos x upon 2 is equal to cos x by 2. Not getting it? Okay, I will just brush my work here. Now 1 second. I will just show you this out. Okay, I will just remove this and then you will understand this. Okay, just see. So if I say double angle, so can you write, instead of this, can you write 1 plus cos x is equal to 2 cos square x by 2? So tell me what will be cos x by 2? Root of 1 plus cos x upon 2. So 1 plus root of, I can say root of 1 plus cos what? Theta upon 2. Similarly here, root of 1 minus cos theta upon 2. Now 2 gets cancelled. So this will be root of, just see, 1 minus cos theta upon 1 plus cos theta. Now I am just solving this on this side. Okay, just a second there. So 1 minus cos theta. Now why I did this? Because cos theta value I know. That is what exactly we are asking us to. They are asking us to find the value. So cos theta by 2. So cos theta is nothing but, so what is there? It will be root of. It will be root of. Okay. Why it will be? It will be root of. I take it here. Okay. Root of 1 minus root phi upon 3 upon 1 minus, yeah, 1 plus root phi upon 3. Now if I work it out further, what happens? This will become 3 minus root 5 upon 3 plus root 5. Now if I rationalize the denominator, so this will become square root of 3 minus root 5 upon 3 plus root 5 into square root of 3 minus root 5 upon 3 minus root 5. So this root will go upon a plus b, a minus b inside root sign is a square minus b square. So it will be square root of 9 minus 5, which is equal to 3 minus root 5 upon 2. So I think I am very clear, my B option is the right option. So it's not difficult. If you see the previous questions, that chart, which if you remember the chart over there, the chart, with this chart many sums you can solve. So basically what you need to remember is this thing: for sine inverse, tan inverse and cosec inverse, minus pi by 2 to pi by 2, except for cosec inverse is minus pi by 2 to pi by 2 less 0, minus 0, because 0 cannot be the principal value. So this is also called as principal value branch, keep that in mind. Then based on that domain, everybody knows, I saw 2-3 sums on that. So this is what the pattern is. So we will be doing more questions, more sums, and I think on inverse trigonometric function, and now you will be able to do little bit quicker and little bit faster. Time and again, whenever the reference has to be there on this, I will get it back to you on the screen, so that keeps your memory fresh on inverse trigonometric functions. So children, thank you very much for watching the explanatory video for understanding the MCQ, how to do the MCQ using the foundation module on inverse trigonometric function and followed by the MCQ module. I wanted to watch both. It might cost you 1 hour or 1 hour 15 minutes, but it is worth spending time, because the next 50 questions of inverse trigonometric functions on MCQ, you will be able to do minimum 40 to 45 sums on your own. So thank you very much. God bless you. I catch you up with the next session on MCQ 2 of inverse trigonometric function. Thank you very much, and stay safe and stay healthy. Bye bye.